What's up, guys? Welcome back to part 2 with Tyler. There's actually going to be 2 more parts with Tyler, but it's going to be refrigerant leak checking. And we're going to get into everything with nitrogen and soap bubbles, with an ultrasonic, with an electronic leak detector, with UV leak dye. All that stuff is going to be covered in a 2-part episode coming next. On the last episode with Tyler, you'll notice that what happened is there was an AI intro. Now, sometimes this gets thrown in there if there's a problem with my audio when I send it to the editor, if there's a technical difficulty, they'll do me a solid and fill it in with AI, but that's why that was there on the last one. Anyway, guys, let's get back to this. This is the HVAC Know It All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. I was thinking about, you ever seen like the movies where some guy's got like, I don't know, gangrene or something, and he's got to get his leg cut off, and the doctor gives him a bottle of whiskey and ties a
like tourniquet,
something around his leg, and uses a big stainless steel saw, and he's like drinking the whiskey and biting down on a broomstick or something like that. Right. So that was a medical procedure back in the day, and like imagine
things have evolved
now, it would be unacceptable. So yeah, I get it. But I want to ask you a question. You're saying EER. How do we check the EER with your setup there? How do we do that?
So if you have your multimeter and you get your voltage and everything else and your electrical data, if you feed that in, whether it's using the app or the actual manifold, we can actually generate with the software we have in the manifold and in the app, we can actually generate the EER for that system.
So by using the saturated temperature, superheat, subcooling, and the meter readings, we can generate that?
Yes.
Okay.
Yep.
So we don't need anything we don't need temperature in or out of the duct system or anything like that?
No, because what we're looking at the amperage draw. We're looking at what it's drawing for power, and we know whether or not a system's under duress, because that's what that information is published based on electrical usage. It's like a car with gas mileage. It's based on how it's using the fuel. It's the same thing with this. It's how it's using its electric, and that's how we know. We're going to have probes hooked up simultaneously, meaning I would. So I can actually, if its EER shows it's under duress, then I know it's under duress, obviously from pressure. So here's what I do in that instance. This is my recommendation for someone that's going to use a product like ours. When you get there, whether it's your new customer or an existing customer, when you get there, you hook it up and you just do that EER right out of the gate so that you see it. So if you see that it's off, based on obviously pressures will give you an idea, but if you see that the EER is low, then you're going to look at all your pressures and all your other data, your super, your subcooling, and all those things. Then you're going to know whether or not your condenser, aka your heat rejector, or your coil, aka your heat absorber, whether or not they're misbehaving. And you're going to go to those necessary parts or components and deal with it. As you've spoken about the refrigeration cycle, and I've done it because I just did a national RSES presentation recently. We both know that cycle is basically an assembly line for the use of refrigerant. Each component handles its responsibility and passes its finished product off to the next component for it then to, phase change it, convert it, drop its pressure, whatever. If it's medium price, drop its pressure, whatever it might be. So we know based on those readings what to go after and what's under duress. So if we're going to fix something, obviously, if it's the appropriate fix, Gary, the pressures will obviously come in line, but the EER will go up. So we're able to, again, people understand efficiency. If you're a good technician, you could take the EER related to the SEER, and if you're really good, or if not even really good, but if you take it a step further, you can relate that roughly to an actual percentage efficiency. So for example, if I have an 18 SEER condenser, right, and I know if I'm getting full 18 SEER, which is what I have in my house, I know in the percentage of efficiency world, as far as comparing it to 100% efficient condenser, which doesn't exist, I know I'm probably around a 94% efficient system for air conditioning, roughly. Okay. Whereas if I had a 12 SEER or 13 SEER, I know I'm at like a 90. So you can relate things to certain things. So if you're able to do that, it just gives you a leg up, I think, in selling something. And again, justifying it with the reporting and everything else that you have at your ready. So it's just another tool in your arsenal to make you a better technician and to state your case for your customer.
Yeah. I mean, it's no different than using like an IAQ meter or something like that to say, hey, maybe we should upgrade your filter or put some ventilation in this home or put some dehumidification in. sometimes if it's hard to sell these things, or I don't like using the word sell. You are selling it, but it's hard to recommend these things and put them into action without the correct evidence to put into place and to back it up. Anyway, so we talked about that manifold for a bit, but you said probes as well. So you got a probe set, refrigeration probe set?
We do. I don't have with me right now. My kit's not with me because I just was in Cleveland I just got in from Cleveland like almost midnight last night. So it's actually staying out there because I'm going back out to see a Johnstone Supply Group out there for a whole kickoff that we're doing out there, but where their customers, I should say. But yeah, we have a manifold and probe set. So the probes we have, I could actually probably bring them up on my screen and probably share my screen if you wanted me to.
Yeah, that would be cool. Yep.
But we have wireless probes, obviously for both your liquid line and your suction line. We have the vacuum probe. We have psychrometer. We also have a digital scale, Bluetooth scale. And we also have two vacuum pumps. We have a 3 CFM and a 6 CFM. Both are 2-stage. So let me see if I can bring this up here on the fly. If you want to just give me a second, and I will share my screen.
Oh yeah, there we go. Yeah, those are pretty sexy looking.
Yeah, not bad. So I'll just kind of blip through. You don't need to see my face, but we're on Measure Quick for both.
That's the combustion analyzer. Sorry.
Yep. The combustion analyzer on the left, manifolds on the right, and then this is just an example here. If I can highlight it, right here is the amount of the Measure Quick reports that can be generated for somebody. So it assigns a system a grade. Remember, we were talking about making things easy for our customers. So it assigns the system a grade. So we have that on there. But real quick, let me just get through. So this is the manifold. Then we have one of the things too with the temperature clamps that we have, Gary. We have both wired and wireless. They don't slip off the pipe, and once they grip, they grip. You know, some of them that slip off, so they grip and then they slip like this, and you lose your contact point. These actually, when they're secured, when they're clamped on, they stay. And we also have a separate accessory for those larger pipes.
Yeah, what I was going to ask you, what are the pipe sizes we can do with the initial clamps and then the step up?
I believe it's just as low as like 1 1/8, I believe, and up to 7 3/4 inch pipe. So we have many ways to get to Rome. So the two different temperature clamps do those small through medium size, and then for up to that larger size, we have a separate Velcro style type of a temperature probe on there that actually goes on those kind of pipes. So we have that as well. What else we got? So we have the app that goes with it too. You know, without being too product heavy here, and then we have the case that looks like the nuclear football case if you're a government official. So we have that you put the launch codes in, so to speak. And then we have both 2-channel, which actually is a 3-way. We both have a 3-way and a 4-way manifolds. Yeah, they're called charging manifolds for a reason. But if somebody wanted to pull vacuum, which we all know is purist, that's not the traditional way to do it. But we have one if somebody wanted to do that with the latest and greatest in both technology, but also durability for internal components. Pirani sensor in the vacuum probe. We also have micron gauges built into here. It goes as low down as 50, upwards of 25,000 microns. You can hit it with positive pressure of up to like 380 psi, which a lot of them only go to like 140. If it's gonna get banged with positive pressure, it can really screw things up. So for the micron gauge, so we have it covered there. So we know, if we read between the lines, we know how someone's going to use it. We also know the pitfalls of what can happen while being in use. So we have that downside protection to protect the end user in case something gets a little hairy or gets out of line.
Yeah, I do want to bring something up though, because I think it's really interesting, because manufacturers are still making manifolds, and that's not a secret. Although the use of probes is getting heavier and heavier and heavier, and if you want to avoid cross-contamination, stuff like that, probes is probably a good bet. But people ask me, well, why are manufacturers still making? I think that the manufacturing of manifolds will start to decline over the next 10 years. Like in 10 years, people might be like, okay, no more manifolds, it's just probes. Okay, this is just kind of a prediction of mine. But right now, people always ask me, why a manifold? Why a manifold? And I said, well, because there's still a market for it. There's technicians that still want a manifold in their hand. That's why. Because they don't want to move to probes yet. This will happen eventually as sort of the Generation X and the boomers and maybe even the later millennials start to move out of the trade and the younger ones come in and take fully over. It could just be all probes at some point. But right now, techs still want to hold a manifold, some of them. So that's why manufacturers are still making them. Would you say that that's a correct analysis of that?
That is correct. It's almost, first of all, it's muscle memory for them. So if we're going to get them away from an analog gauge set, Gary, the first thing they're probably going to migrate to is a digital manifold like this. So they have that security blanket, so to speak, and I say that in a complimentary way, not in a negative way, but the security of knowing that they're actually looking at gauges themselves just in digital format. So we're looking to almost make it mimic what they would see on their phone, and we'll get to that in a second, but we're seeing it in an actual hanging type of a gauge set. So they're kind of going from one mountaintop to the other. So they're going from the analog mountaintop, jumping up a little bit, going into a digital manifold. Now, as you had said, and as we have seen out there in the space as far as research that we've done, so we give you the ability to take this manifold and hook our wireless probes up to it, which also simultaneously hooks up to our app. So if you understand that and you're not one that requires the use of a manifold, you can just go straight probe and app setup. So you're good to go. You just get your hoses, you go straight probe and app setup, and you're ready to fly. Put on your charging tee, whatever you're going to do, your different configurations on there, but you're ready to go. That is probably the way of the future, as you had just mentioned, where you think it's heading, and I think it's heading in the exact same way, because I think the amount of things that can be done on a phone or tablet, although we're highly sophisticated now with the apps that we have and others have out there, I think that's going to further evolve, and that's going to make it better. And also, too, if someone is hooking up hoses to the manifold, you also know that you're losing some refrigerant. If you're hooking up your probes, it's just, it's not the same refrigerant loss as when you're hooking up the hoses to the manifold onto your liquid line, your suction line. So there's that part of it too, from not only from an environmental standpoint, but from a refrigerant standpoint. And we all know how expensive R54B is becoming, and that is it's like buying liquid diamonds now, and it's becoming cost prohibitive. I've even heard of. I was just telling some contractors on a visit I just took, been hearing of contractors buying extra R54 systems and taking the refrigerant out of it and bringing them back and saying, you know what, I over ordered, I don't need this many. And they're sending them back dry. And yes, they're sending them back dry and no one's noticing. And not noticing until it's too late. So yeah, I've heard of that being a practice now. So around the country. So just be careful by your neck of the woods, because that's, I guess, desperate times call for desperate measures, and that's what people are doing. And yeah, I've heard of all kinds of things taking place out there, unfortunately. So it's been interesting.
I'm just gonna go fill mine with some R22.
Call it a day.
Yeah.
Awesome.
The other thing that I want to bring up too is along the same lines of what I said, is there's still a market for it. Now, a lot of techs are moving to the practice of the equipment straight to the vacuum pump with a single hose. But you have a 4-port manifold on there, and pretty much every manufacturer still has a 4-port manifold on there. And anytime you talk about the single hose or 2-hose setup coming straight from the equipment to the vacuum pump, you always get half or more of the techs saying they still pull with a manifold. So again, there's a market for it because they're still comfortable doing it that way.
There is, and we've actually, from the pre-orders that we've gotten, there's a really good market for it. Our pre-orders have far exceeded what my estimations would be, which maybe makes me not good at my job at times, but it just, I go into it with tempered enthusiasm, and hoping for the best. And the pre-orders that we have received have been astronomical. It could be because the analyzers in the market have established us with a nice reputation. So we have some fanboys and fangirls out there, which I am over the moon about having, but also just the name of the company's gone out there. So it's been great. But yes, we're seeing more of those 4-port ones being ordered than we had expected. One of the other things too, Gary, with this is the recovery and evacuation. Now, we don't have a recovery machine, but I know that is an interesting process out there as well. And I really don't make any recommendations to you, but if I can make one to you, I strongly recommend that you have on someone that I've been heavily aligned with now for the last 4 years. He actually happens to be a rep of mine. And in the States, he's considered to be in the top 2 for recovery and evacuation trainings. His name is Jeff Hutton, and he works for my rep group called ETS, which stands for Excellence for Training and Sales. And he does extensive recovery and evacuation trainings. And he might be somebody that you might want to have on. Yeah, Jeff Hutton from ETS, I think he could lend a remarkable perspective. So you've been very complimentary of me with the combustion and everything else, and now obviously the refrigeration things, but the combustion trainings is for YouTube and all that. I appreciate it. But he does the same kinds of things for recovery and evacuation. and he is literally everywhere we go. He is just, his reputation is, if there's a score higher than a 10, he's over a 10. And it's someone that I strongly recommend that you get on, because I think it will be, not that anybody else needs to be educated further. I don't know anybody's level, but I think it will shed some light on a topic that needs some better definition and how it should be done for best practices. And I think it would be interesting to have him on, because that's what he would talk about. It's all processes for him, and that's how he teaches.
Amazing. Okay, cool. All right. I mean, audience, me and Tyler talked about almost like a refrigeration 101 type episode, possibly recording next week to be put out a couple weeks from now. So teaser, let's give a teaser on that. Just give me 2 minutes on what we could talk about on the proper ways to check for refrigerant leaks, and then we'll end it off for today.
So one of the things we want to cover is there's been people being overly paranoid, first of all, whether or not their current refrigerant leak detector will work for the new style refrigerants. So that's one of the things that we want to cover. And so, if it's a blend, which R54B is it a blend of R32 and R1234Y, can it detect it? We want to talk about that. We want to talk about how to properly go after a leak. We want to talk about the proper administering of leak of UV dyes and leak checking and all these other different things that's another reason why we don't want to pull. You talk about a 4-port manifold, Gary, when you're pulling vacuum through that. When you're charging a system, you're using fresh refrigerant. When you're pulling a vacuum, you're pulling all the impurities in that refrigerant. You're also pulling that through a manifold, so that's one of the, going back to when we talked about the actual vacuuming function, or the function of a digital manifold. It's one of the reasons why we want to keep that manifold as pristine as we can. Just going into the different things when we're looking for a leak and what we're doing. So that's something we can discuss in a couple of days, and also how just all this stuff relates to the refrigeration cycle. I mean, there's a lot of technicians listening to this that might not understand the refrigeration cycle, and they don't understand what the metering device does. They don't understand what the compressor is supposed to do. They don't understand what kind of refrigerants, whether it's liquid or vapor, is passing through. They don't understand. A lot of people think that when you raise a temperature, it's boiling. It's not. When you raise a temperature past the boiling point, it becomes a vapor refrigerant. A lot of technicians don't know that. So I think that wrapping some of those maybe misunderstood basics and maybe making it into a way that everybody can easily understand, makes us, in from a training perspective, makes us solutions providers, because that's what these technicians are. They're solutions providers for people, and we want to be solutions providers for them as far as just giving them proper information out there. And I'm just one voice of a universe of excellent trainers out there, especially on the refrigeration side. There's so many incredibly knowledgeable people out there, much more knowledgeable than myself doing this. So I encourage everybody to get those different perspectives.
Amazing. Okay, Tyler, can't wait to talk about that next week. But for today, we'll wrap it up. And I thank you for your time today, man.
Got it, Gary. Thank you so much, sir. Appreciate it.